Oftentimes, when you get an STL scan of a part file, it opens up with problematic geometry regions, extra scan material, or missing regions altogether. If the part you are trying to reverse engineer is truly important to get into workable geometry, you must find a way to properly clean and fix the mesh. This lesson will cover the ins and outs of the Facet cleanup tools in Ansys Discovery. Let's import an STL scan file and go to the Facets tab. Whether or not the file has obvious visible errors or problematic geometry, you should always use the Check Facets tool first thing. This is done to identify any problems. If there are problems, you can then use Autofix to try to fix all of the problems at once. Or you can use the holes, sharps, intersections, or overconnected tools individually to fix those respective error messages. Smooth, reduce, and regularize are useful tools to adjust facet regions. Smooth will smooth out a selected facet region. You can define an angle threshold, flatten peaks, add facets, or be volume aware. The Reduce tool allows you to reduce the number of facets in a selected region. The Regularize tool can help make facets consistent in a certain area. If you would like to get a consistent facet size across the entire mesh, use the Shrinkwrap tool. Let's activate the Shrinkwrap tool. Notice the Shrinkwrap options appear and prompt you for a gap size. The smaller the gap size, the smaller the facet size will be. This also will equate to a larger file size. The advantage of using a small gap size is that the resulting mesh will be very accurate to the original mesh shape. But if you wanted to eliminate certain regions of inconsistent geometry, a slightly larger gap size is recommended. Let's demonstrate this by using Shrinkwrap with various gap sizes and comparing the results. You can see here how the smaller gap size results in a finer mesh, but it does not smooth out possible unwanted details. On the other hand, the larger gap size results in a coarser mesh, but does smooth over some of the smaller details of the part. Therefore, choosing an appropriate gap size depends on what type of result you are looking for. Before moving on to the reverse engineering methods, it is important to note a few other useful tools in the Facets tab arsenal. These being the Separate, Separate All, and Join buttons. Say you open your STL scan and it has dozens or even hundreds of individual small mesh pieces that are not connected, but the structure tree still identifies the entire group of geometry as one mesh body. As this is likely an error with the scanner when it generated the STL mesh, you can click the Separate or Separate All options accordingly to separate out the pieces of the mesh. Or, if you want to join a group of mesh bodies back into a single mesh body in the structure tree, you can do so with the Join tool. In the next lesson, we will learn how to use the reverse engineering tools in Ansys Discovery.